Thanks, Mark, and thank you to everybody that's in attendance for this webinar. What we're going to run through during this webinar is an introduction to Microsoft Cognitive Services, and more specifically the Bing Search APIs that fall under with that umbrella. For those that aren't familiar with Cognitive Services, they're a collection of AI services that can be consumed over the web that typically fall within these five silos, those being vision, knowledge, language, speech, and search. Within each category, there can be multiple APIs. So for argument's sake, for example, in the vision API, we've got there's APIs that can undertake facial recognition, that can automatically index videos for you. Another example is the knowledge API, which is a really good set of APIs that can be used to power chatbots and language understanding. But the ones that we're going to be focused on are the Bing Search APIs. Now, there are quite a few to get through. At the time of writing, there are about 9, which we can see here. So we've got web search, visual search, custom search, and some others there. But the ones that, before we, so if we can move on to the following slide. Before we move into the detail of the 3 APIs that we're going to look at, from a developer's perspective, some of the key reasons why you might want to use these search APIs is because, in my opinion, is that a lot of the heavy lifting has already been done for you. Consuming these APIs is relatively straightforward. More often than not, you only need to make one single API call, pass in your parameters, and then get the data back. There's billions of indexed data sets out there on the web that are available for you to grab, and using the power of Bing, you can just, as I say, consume those data sets in one API call. Another good thing is that it's easy to provision these services in the cloud through Microsoft's Azure portal. So, and what this basically means is that if you're building products or sets of services, it frees you up to do other things. You may have other things to build other than search, and it just, it makes product development that little bit more simpler. So you can, optimize the functionality that your application provides. So we're going to look at 3 APIs. As I said, there are 9. We're going to focus on 3. The first one is the Visual Search API, okay? And effectively what this API lets you do is take an image, whether it be on your local file system or in the form of a web URL, and send that over to the API, right? And effectively what you've got is bing.com/images. You've got that search capability in a box, okay? And when you send that image to the API, you get some rich metadata back, basically, right? But over and above that, the API ships with a bunch of features, which we can see on this slide. So for argument's sake, the first point here, visually similar products. Well, you can take an image, send the binary over to the API or the URL, and the API will return information in the form of JSON that lets you know on the internet where products are kind of similar to the image that you've just uploaded. Another cool feature is the shopping sources. So that feature, what you can do is you can take a picture of an image, send it over to the API, and then it will return actual online resources where you can buy products that match that image that you have just uploaded. I think that's a pretty cool feature, really. Under the hood, it's doing a lot of heavy lifting for you, but you effectively just have to pass over the image and you get that list of shopping resources back to you. So in this, what we're looking at here, though, right, is that if you look over to the left-hand side here, this is this web page actually exists on the Microsoft website. So this image has been uploaded to the Visual Search API. If you look over here, what we can see is we've got a list of images that were brought back that are kind of similar to this image. So you can see just by looking at the pictures, they are similar. It's a chair, it's blue, but more importantly, it's been able to pull back some other metadata, like the price, for argument's sake. It's also got the locations of the image, the URLs, down to the dimensions of the image itself. So you can take that data, and there's a lot of different things you can do with that. Another neat feature, and I read a story a few weeks ago, Argos recently developed a native application that allows shoppers to take pictures and then basically find those products that are kind of matching that in their catalogue. Well, I'm not saying that Bing was used here, but Bing supports this capability, or this API rather. So there's no reason why you couldn't use the visual search API to take a picture, run a search, and then bring back the shopping sources that sell the product that you've just taken a picture of. Now you could take that a step further, and you could sub-filter the result sets based on, you know, some other business rules or business logic that you've got, maybe based on, say, price, for argument's sake. Another cool feature worth mentioning is when you take a picture, the API will do its best to identify key points of interest in an image. So if we look here at this image here, we've got 3 blue boxes, and those are called bounding boxes. So down here we've got some sunglasses, a bag, and some we've got a watch. And then over to the right here, you'll see that the API has been able to identify like each component that forms this picture that may be of interest. So it's identified all 3 parts that it feels that are important in the image, and then it's made a call out to the web, and it's pulled back similar products. So that actually opens up quite a lot of possibilities as well. So you get everything down to the description, the price range, even down to the ratings on some of them. Again, there's just a lot you can do with with those data points. From a developer's perspective, I mean, this is a common theme, right? And this applies across the board and isn't just specific to the Bing search APIs. It applies to like the whole of the cognitive services stack. Is that consuming these APIs is relatively straightforward for developers, and there's a few different ways that you can integrate them. You can handcraft the code in a language of your choice, whether it be a .NET language or another variant, or JavaScript for argument's sake. You can consume the REST endpoints directly, or for most of the cognitive services APIs, you can actually just use a dedicated SDK, which encapsulates a lot of the low-level calls that like a developer would often have to make. So it just shields you from building up the low-level REST requests. And what we're actually looking at here in this code extract is a real live code example of the API being called. Now, granted, there are some functions in here, or methods, and we've got the code for this on the GitHub repo online, which we can share at the end of the session. But effectively, it's less than 50 lines of code to harness the power of the Visual Search API. Typically, what it involves is getting the image binary or the location, and then constructing the request, and then sending it over to the API. Quite a few different use cases for this. We've kind of talked very briefly over some of them. Everything from recommendation engines to deal scanners to actually, ensuring that your IP or your copyright is being maintained. So you could upload image-related data. You could take pictures of products and build a service that automatically, ingest image-related data, makes a call to the API, and then surfaces the cheapest deal. That's one solution that you could build out using it. Recommendation engine would be another one. An e-commerce site for argument's sake. You may offer up a set of services or products, and then when the user gets to the checkout, you may auto-suggest other products from possibly other websites or partnering websites. There's a lot that you can do with it, and I would encourage anybody that's interested in using image as search rather than just text to explore the Visual Search API documentation, which is you can find online on the Microsoft site. and it ships with quite a lot of different examples as well in various different languages. So that's there's plenty of resources as well there. So that kind of wraps up the visual search API. The next one that we're going to look at is the Bing Web Search API. Now, what that is, excuse me, it's effectively Bing in a box, right? And using this API endpoint, you can make a call to that API, and it will effectively run a search against Bing, and it'll bring back information that's in the form of web pages, images, videos, or news. And some of the features, you get the features at the box that you would kind of expect from its web-based counterpart. You can filter the results, you can page through them, and you can even localize the search results based on the country or market that you're in. One add-on that you've got is though that you don't get on the website, obviously, is to plug in the statistics module through Bing, and what that gives you is more in-depth analytics in terms of the search results that you're getting back. And I think this is like one of as a developer, okay, this is like one of the kind of selling points for me actually, is that, so if we look at this slide, we've got a request that's been made, the query is NASA, and then here we're looking at the search results, okay? Now there's quite a lot going on here. We've got web results, we've got some deep links, we've got news articles, image related data, videos, and we've got related searches. Now that's quite a lot of information to parse out. But one of the cool things about the Web Search API is that when you make a request to this API, the data that you get back is grouped into a nice little object model, which you can see in this middle section here. So each response is structured in this fashion, okay? And what that means is that you've got a nice object model, object-oriented set of classes that you can just interrogate and work with programmatically. So you're not having to deal with low-level HTML nodes or attributes and passing out the result sets that would typically be involved as part of this web page. Again, from a developer's perspective, like the visual search, it's real easy to consume this API. Consuming this API is much more simple than the visual search. Less than 20 lines of code, and to be honest, it's probably about 10 lines of code. Here, this is an actual live example of making a call to the API endpoint. So we can see we're setting up a client, we're adding in our Azure key, and then this section here is basically just making a call to the API endpoint, and then we emit the response in a little console application. We've also got the option to use a dedicated SDK, or you can handcraft the code as well. And again, like all the others, you can use a language of your choice. From a developer's perspective, and we kind of touched on this on one of the earlier slides, is we get back a nice rich object model, which groups the data sets into the respective categories, whether it be entities, images, related searches, so on and so forth. If you look over to the right here, you can just see like a subset of that data. So we've got like the web search URL, content size, the host page, and all that sort of thing. But don't take my word for it, right? What I'd like to share with people on the call is a quick demo of the web search in action. So if you just give me a couple moments, what we're going to do here is we're going to swap out of the slide deck and into Visual Studio. And okay, so hopefully everybody can see my Visual Studio. So what we're looking at here, we've got a set of console applications. Again, this code's available through the Code Matters blog, which we'll share towards the end of the webinar. And what we're looking at is a simple console application where we set up the client that has to make the request. This is your key, which you can provision online. We add in the Azure key to the request. This is the web search API endpoint. We're passing in the query. We don't have a query yet, we invoke the web search API, and then we output that response in a console application. So what I'm going to do here is I'm going to jump on, I don't know, to like BBC News, and then just pick off a story. I'll pick Brexit, that's in everybody's news feeds right now, so I'll do that, and then we'll put a breakpoint on this line of code here, and what we'll see is the console application will spin up. The query Brexit will be added onto the web search API endpoint, and then when we get down to here, we should have some data back. So I'm going to run that. Excuse me. And so we've got a response code back from the web service, status code of 200, which means it's been successful. At this point here, what we've done is we've just invoked the web search API with our query, which was Brexit. This is the response. Now this doesn't make a lot of sense right here because it just looks like one big long stream of data. But what we can do is we can look in the JSON visualizer, and what we'll see here is the data that we've got back from the web search API. Okay. Now if we look here, that's our query, which was Brexit. I'll expand this. And then we've got all these other nodes: web pages, entities, news, related searches, videos, etc. So if we expand web pages, we'll see there's about 17 million web pages to match the query that we've just sent over to the API. If we expand the value node, we've got the first page of data. So we've got a URL from the Independent. We've got some other metadata here. The Guardian, BBC. I won't go through all of them, but you get the idea. Entities is, if we expand that, so what the API is attempted to do is identify any entities, and those are things that are of interest, or items, or topics that are being discussed in the query. Now it's identified at Brexit, and so it's looked at, it's tried to find out, well, give me a definition of Brexit, and we've got a definition of that here. We've also got like the web search URL that was used to extract that data. There's some news sites as well, BBC, Sky, The Sun, The Mirror. There's like quite a few different websites, and then finally we've got related searches. Okay, now, so we've just keyed in Brexit, but other people are saying good things about Brexit. Other people are saying advantages and disadvantages. So that just kind of like, that was a quick run through really of a console application that shows you, in probably about like 10 to 20 lines of code, how easy it is to consume this API and visualize the data that you get back. Now you don't have to deal with just a string. You could create your own object model and map this data to a rich set of objects. It's purely your decision. And if we just run through the application, we'll see we get all the data back in the console application. Not very nice to look at. That's why I just thought I'd show you everybody it through the JSON visualizer. So as I say, these code examples are available online, and we'll share those resources with you at the end of the webinar. But if we jump back into the slides, so there's a few use cases really for the web search. This list isn't exhaustive by any stretch, and this is another cool thing about these APIs in general. Actually, is that you can blend them. So for argument's sake, you can take the web search API, okay, and then take the text analytics API, and so you can scrape data using web search, and then you can run a layer of intelligence over it by way of the text analytics API and use that to surface popular topics or keywords, or even the public opinion on news stories, current affairs, products or services. You could take that a step further and aggregate information from loads of different sources. So not just Bing, but social media feeds or CRM databases or anything that's got data. You can bring it all under one sort of solution to create like your own custom news aggregator. And when you've got the data in a format that's suitable for you, you could even visualize that, whether it be in a custom ASP.NET web application and or some Power BI dashboards. Other uses for this web search API could be in plagiarism detection. So what you could do is if you've got content and you want to check out that it's not being duplicated online, well, you could take extracts of that, make a call using the API, see if you get any results back, and then send out an alert or an email or carry out a set of business rules in your application. It's really it's up to you. Fraud detection is another example. So what you can do is that you can use like the web search API and in theory the image search API to like trawl the web for websites that contain images and URLs that are similar to yours. And then if you identify those, then you've potentially got a website selling counterfeit goods or things like that. So that was that kind of closes out like the web search API. Quick to consume, rich object models, and it just you get Bing in a box effectively, and it shields you from writing like low-level code to parse out all the raw HTML that's often associated with internet data when you're running search. For the developers in the audience, they might be familiar with the HTML agility pack, and that's like a common technology that's often deployed when parsing out HTML or writing screen scrapers and stuff. Well, with this API, you don't need to do that. So the final API that we'll run through is the custom search, and so custom search is an API and a solution, right, that lets you build like your own custom search instance. It runs off the whole premises of what it calls an instance, right? So rather than the web search API, which calls it into Bing and grabs you loads of data from the web, with the custom search, you effectively build out your own search engine, okay, that can return web, image, or video data, right? The key thing about this API or service is that you've got total control over the data that search returns and the data that's available. So like, and what you can some of the other cool features of the API are that you can inject automatic spell correction, auto suggest. You can even promote certain sites. So if you've got an environment where almost like maybe like a wiki, or say you don't have SharePoint, but you need a search facility or a search experience within your corporate intranet, well, you can build a custom search instance and configure that in such a way that it will grab data from various internal websites or external and surface or prioritize the websites that are important to your users or customers. And one of the good things about it is that a lot of the configuration and setup can be done online through a dashboard. So if we look at this slide that we're looking at right now, this was when I ran through this like a few weeks ago, I added my blog. All you need to get started is a Microsoft account and a cognitive services key. And what you do is you log in, you add one or many URLs to your search instance, and what starts to happen is it starts to build up a dictionary or a catalog of the data that your search instance can expose. So what we can see here is I've added my blog over here, and you could add multiple sites here, and it auto suggests sites as well. If we look over to the right, we can see I've keyed in a query here called Twitter. The search instance has then made a call to the resources that I've configured and brought back the articles that it feels are most suited or are most suitable. And whilst you're in here, again, all just point and click interface, you can either boost this site or demote it, block it, or pin it to the top. Okay, so you don't really need to be a developer to configure a search instance. This dashboard is pretty user friendly. The next thing that you can do from the dashboard is that you can after you've set up and provisioned your instance with all its data sources, you've prioritized or demoted the sites, and you've got your data and it's good to go. The next thing that you can do is and this is optional, is that you can create what's called a hosted UI widget. Before you deploy that though, you have to configure the look and the feel. Excuse me. But again, you can do that through the online dashboard. It's actually just one of the next steps. So you pick the layout, you can pick the colors and the themes, and then you get an update over to the right-hand side here in real time as to how that's your search widget is actually going to look. So you can play around with that and tweak around with that as you as to get it to suit your requirements. And then when you're happy with that, what you can then do is you can publish that to a test site. Now, this is actually a live test site that because I'd followed the process, and I'd picked the default color schemes and stuff. I'd published it, and you can see up here it's got the custom config ID, which is like one of the unique keys. I've keyed in a search term, cognitive services plus Bayesian theorem, and what it's done is it's interrogated my custom search instance and brought back the articles that are relevant. And you can see that they are, cognitive services. Well, it's mentioned in the result sets. Bayesian theorem is mentioned as in there also. And then when you've done all that, what you get at the other end is you can get a JavaScript widget. And what you do is you take that JavaScript widget and then you drop that on your website, and then you've got the search instance available for your community to run queries against. So that covers kind of like setup, provisioning like a UI widget, and then how you can drop that onto a website. But you may want a little bit more control over that. You may not want to immediately expose that just as a search instance, a search widget on a website. So from a developer's perspective, when you set up the service and got the data in there, you can consume that search instance programmatically using the API, just like the others. Again, use a language of your choice, very little code, or you can use the SDK. The code example here, what I've done is I've created my own custom class. Sometimes I just like to do that rather than use the SDKs. It's just personal preference, really. It just gives me a little bit more control over the data points. You don't need to do that, but it's just, as I say, personal preference. And as I say, this is a common theme through all of the APIs. They are pretty straightforward to integrate. So what do you get back when you consume that API? Well, you get the URL, you get the unique identifier for the API endpoint, and you get the name of the web page, the URL, and some other rich information as well. I would encourage anybody that's interested in building against this programmatically to look at the API reference guide, not just for this, but for all of them, because we're just highlighting some of like the key points here. And when you go online and look at the developer reference, you'll see they're all set out in a standard fashion, so it's easy to dip in and out of the different APIs. The documentation and the help sites are all structured in the same way. So like, what about the use cases for the custom search? Well, I suppose I kind of touched on this, but you can get, when you've got your custom search, okay, so you could have data coming from websites or corporate intranets or other online resources. Well, you could take that data and then you could consume data from, for argument's sake, from social media feeds in the form of maybe like Facebook, Twitter, or custom CRM data. And what you could do is you could surface data from a variety of different sources in your search instance. The other thing that you can do is there's another add-on, which is the custom auto suggest API. So in addition to like building your custom search instance with your defined sets of resources and URLs that are unique to you, you can prune that search experience and give users a better search experience by adding in the custom auto suggest. So as they're typing, you can funnel them down to the data that's important to them, rather than them having to key in loads of different search criteria to get at the data they want. Finally, another cool way that you can deploy this is like you can build safe web browsers. I'm thinking here, building like web browsers for kids effectively, or even you could build a native app that runs search, okay, but under the hood it makes a call to a custom search instance. So you've total control over the data that's served to like say a kid's web browser, So I think that's a really good use of the technology. So that wraps up the kind of overview of the three of the APIs. So what we've looked at is visual search, web search, and custom search. And what we've seen is how it can be how easy it is to like call these with like very few lines of code, and how the barrier to entry for deploying these AI powered services isn't that high. Effectively, this stuff's been democratized. I feel you don't need like a PhD in text analytics or search to get the benefits of it anymore. You can pull these APIs off the shelf. So with that, I'm going to hand back over to Mark. I'd just like to thank everybody for their time, and yeah, so thank you.